Hello friends, so welcome to engineering tutorial. So we'll continue our discussion related to equations of motion. In the previous videos we discussed about the four equations of motion which we derived using the method of integration from the standard formula which is there for velocity, acceleration, displacement, all that. So there is another way in which we can derive the same expressions, the same equations, which is using the graphical method. Okay, so for that let us start with an object, let's say at time t equals to 0 seconds, okay, with an initial velocity u, then it is moving with constant acceleration a, and then finally a final velocity v at time t equals to t seconds, let's say, and in that it has a displacement of s, okay, a displacement s, this. So here what we have is a velocity time graph, okay, a velocity and time graph. So here at time t equals to 0, the object has an initial velocity u. Okay, this y-axis is the velocity axis, the x-axis is the time axis. So at time t equals to 0, it has a velocity u, initial velocity u, and here it has in a time instant t, it has a velocity v, okay, this one is v. So let us mark these points, okay. So this one is O, origin, let this one be A, let this one be B, let this one be C, this one be D, okay, this, and let here the slope of this curve is theta, the velocity time curve. Okay, so now we have to derive the equations. So from this velocity time graph, the slope of the velocity time graph gives us the acceleration. We have already discussed it. Acceleration is equal to slope of velocity time graph. So here acceleration A is equal to tan theta, which is equal to perpendicular by base, which is equal to BD by AD. So here BD is equal to BC minus CD, okay, BD is equal to BC minus CD by AD. Now here if you pay attention, then CD is nothing but the initial velocity, the magnitude of initial velocity, okay. BC is nothing but the final velocity, okay, magnitude of final velocity. AD is nothing but the time, which is equal to OC, same thing. And here if we substitute these values, it becomes BC is equal to V, CD is equal to U, AD is equal to T. this is equal to a, acceleration. That implies v minus u is equal to at. Okay, v minus u is equal to at, and that implies v is equal to u plus at, which is nothing but the first equation of motion. Okay, the first equation of motion. Okay, this. So here, using the graphical analysis, we derived the first equation of motion. So using the graphical method, we have derived the first equation of motion, which is v is equal to u plus at. Okay, v is equal to u plus at. This one we have derived. Now we will be deriving the second equation of motion. So if you remember, we have discussed in the basic concepts related to motion in a straight line, that velocity is equal to displacement by time, or displacement is equal to velocity into time. And from the basic characteristics of velocity time graph, we discussed that the displacement of a particle in a particular time interval is given by the area under the velocity time graph, okay, which is the displacement the particle. So the same concept we'll be using here. So here if you see this velocity time graph, you can divide it into two parts. Okay, this velocity time graph, the area under it, the total area is O A B C. This entire thing, it can be divided into two parts. First, the rectangle OADC plus the triangle ADB or ABD, whatever you want to call it, this. Okay, so the total area is the area of the rectangle plus the area of the triangle. Now here the area of the rectangle is simply this OA into OC or OA into AD, whatever you want to call it. Okay, OA into AD or OA into OC, because OC is equal to AD. So here the area of rectangle OADC is equal to OA into OC, or we can write it as AD into CD, anything will be correct. So here OA is nothing but equals to CD, which is the initial velocity, and OC is equal to time, this, the time interval. So the area of the rectangle OADC is equal to UT. Then for area of the triangle, it is 1/2 base into height. Okay, the area of the triangle ABD equal to 1/2 into base into height, which is equal to AD into BD, 1/2 AD into BD. Now here AD is equal to OC, which is equal to time. Okay, AD is equal to OC, which is equal to the time interval. Now for BD is nothing but BC, okay, BC minus CD. If you pay attention here, BC is equal to the final velocity magnitude and CD is equal to the initial velocity. So it is equal to V minus U. BD is equal to V minus U. Now we have already derived that V is equal to U plus AT. We have already derived it. So V minus U is equal to AT. So we can substitute BD, which is equal to V minus U, as AT. So here it will be equal to 1/2 into AD, which is equal to T, and BD is equal to AT, which is equal to 1/2 AT square. So here the total displacement of the particle is equal to the area of under the velocity time graph, which is equal to OA BC, which is equal to area of OADC plus area of triangle ABD, that is equal to UT plus half AT square, which is the second equation of motion. Okay, S is equal to UT, which is the area of the rectangle OADC, plus 1/2 AT square, which is the area of the triangle ABD. This is the second equation of motion. Okay, so by graphical analysis of the velocity time graph, we can derive the equation of motion as we have done here. Okay, the second equation of motion. Okay.